Okay, welcome to another episode of Minecraft with Althoren here. I'm going to demonstrate the Portcullis and how it's built and how it functions. Okay, this is a gate. I use glass here so you can see through it and make it more visible, but imagine this all being brick, stone, whatever your flavor is. This particular gate opens and closes. Now you can use this very easily with the light sensor that Red Ochre demonstrated in a previous video over here. I'll include a link to the light sensor at the bottom of the description for opening the gates during the day and closing them at night for monster security, or however you want to do it. Okay, so let's first see how it works. Okay, that was an open, and this is a close. Okay, now the close, notice that those aren't sticky pistons. They don't need to be. They can just stay where they're at. Because what happens is the bottom pushes up sand and then it pulls it back down, opening it up. And it pushes those pistons right back in place. Okay, the reason we use sand is because I haven't figured out another way of doing this. What happens is it pushes the sand up 2 blocks, and then the pistons retract and sand does what it does best, it falls. Okay, so here's a standard double piston stack. What we have is power coming up here because the piston is going to be at that location when we turn on the switch. We want the bottom piston to fire first and then the top piston. Okay, as you see, that works perfectly. Oh, that's where we run into problems. It takes some complicated circuitry to get this to pull back down correctly. The reason we need this to pull down is so that the sand will fall back down 2 squares. If it doesn't pull the piston back down, then the sand can't fall back to ground level. And then you can't get through your gate because the sand's in the way. So, let me describe to you how I do that. First off, we have our button here that sends power through, and notice the 3 blocker relays here. The first one here is set to 0 or 1 tick. I mean, just no delay. The other 2 are set to maximum delay. The bottom pistons here are set to no delay. We want them to open first because you can't push up a piston that is extended. So the bottom piston always has to fire first. Okay, and that's why up here we have this set to delay of maximum at 4. And I'll demonstrate. 1, 2, 3, 4. Some people count them differently, but I say that's 4. Alright. But the problem we have is we want the bottom piston to open first and close last. And to do that, we need to store up a charge so that it remains powered longer than the top does. To do that, we have these 2 pistons here, these 2 relays here storing the power. And let me explain to you why we have this relay here. If you don't, well, then the circuit locks up. That's why we have this relay. It acts as a diode. Now, you can power your pistons however you want. You don't have to use relays on the bottom. You can replace it with redstone. It works just as well. But when you're adding a whole bunch of them together, it's easier to power them using relays. And let me show you what happens like this. You can cut this down to 1 relay. And it doesn't always work. Depending on how your server is running, how laggy it is, you may be able to cut it down to 1 relay here, but I prefer 2. There's less problems. Okay, so that's how we set it up. Now the top here is powered through a redstone torch tower, and then it's the same thing except for backwards. We have these firing first with no delay, and these firing last with max delay on the relay. Now because we don't need these pistons to retract, there's not the extra relays here to hold the power. They just fire and then stop firing. That's all there is to it. That's pretty basic. Okay, so let's show you how this works with a light sensor. Let's see here. Hook this back up to the relay. Okay, now this is what I call my pulsar. It takes an on-off signal and splits it into two different signals. As you can see, there's one wire going to the close, going up to the close, and one wire over here going to the open. It closes, and it opens. Now you notice when I flip the switch, only one of the lights blinks. And that is because I'm taking this on-off signal, which you need when you're using a day and night sensor, and I'm splitting it into two different tasks. Here's the off one and the on one here. How this works is when this is powered, the power will hit the piston first, cutting off the signal. This piston will extend, it cuts off the signal, but the power is still charged here. Let me show you. It's still charged here, and what will happen is when I cut the power off, the piston will close before these relays lose power. So what it does is it sends a pulse. And this side over here is the exact opposite. It works on the off signal now that the wire's powered. So what happens is you get one pulse per wire. It's great. So you can take the light sensor over here. You need we use a bud switch over here, bud T flip-flop, and not just a standard bud switch. It doesn't send a pulse. See how it's a steady signal, the power line? And we do that so that we can power these lamps, and you can power lamps in your city and whatnot, instead of just sending a pulse. Besides that, a pulse is really hard to split into two different signals, because what happens is if you power the the top and the bottom at the same time, as you can see, it breaks sand. Go ahead and replace that sand. You can't have the top and the bottom firing at the same time. So we take this splitter here and implement it for the gate opening and closing. And then we tie this whole thing right here. This is the input for this system. We tie this to the light sensor. So let me give you a bird's eye view of how this works. These lamps right here are simply just demonstration on the side. The whole circuit is like such. Basically you have two relays in front of a wire going up over a block that's being cut off by a piston, and then you switch the polarity using a redstone torch with wire connected to it for the other side. And you can take a solid power and split it two ways. Anyways, I know that was long and drawn out, and it's a little complicated, but I hope that explains how this works. My next video about Portcullis will be the 3-high gate. I did manage to program a 3-high gate. That's very tricky. It takes twice, if not 3 times as many relays to do it. So that'll be coming up. Just check back on the channel for that, and I hope you enjoy.